Okay, we'll take a second and look at this problem. So basically, you know, you're gonna use integration by parts, right? But you have to figure out what's going to be your u and what's going to be your dv. What feels good to be the u is the 11t, but unfortunately you don't know the antiderivative of the arc secant, so it's going to be better to do u be the arc secant of t, or the inverse secant of t. Does that make sense?
Yes.
So u is going to be the inverse secant of t, and then dv is going to be equal to 11t dt. All right, and so then v is what?
11 over 2t squared.
Good. And then du, you'll have to look on your sheet if you don't know it. It's the derivative of the inverse secant of t. And it's on your sheet, it's the arc secant.
Mm-hmm.
Do you see it there?
Yes.
What is it?
dt, oh, well, 1 over absolute value of t times the square root of t squared minus 1.
Okay. And it's, yeah, on the sheet, it is, has a u, like, doesn't have a u prime, but the u that they're talking about is the t. So
let me check.
Yeah, it's u prime over the absolute value of u squared minus 1. But our u here is t, so this is going to be 1, and it 1 over, and then the absolute value of t, and I can just use t here because our limits are from 2 squared divided by square root of 3 to 2, so those are positive limits, so I don't need to worry about the square root, and then, I mean, about the absolute value, and then t squared minus 1. Okay, so now the integration by parts is that the integral of u dv is equal to u times v minus the integral of v du. So in this case, u times v, I'm going to write it as v times u because it feels a little bit better, but it'll be 11 halves t squared, and then inverse secant t minus the integral of v du, and the v, I have that 11 halves, I'm going to put that in front, and then when I multiply the t squared times the 1 over t square root of t squared, the t in the denominator, this t is going to cancel with one of those, so I'm just going to end up with t over the square root of t squared minus 1 dt. Does that make sense? Understood how to do dt?
Yes.
Okay. So now, how will I integrate t over the square root of t squared minus 1?
It's gonna have to be another u sub.
Very good. So yeah, you really don't have many things to integrate, right? It either shows up on your sheet or you have to do some sort of manipulation. But if you let u equal t squared minus 1, then du is going to equal 2t dt. And you have t dt right here, right? So that means 1/2 du is equal to t dt. So we're going to have this 11 halves t squared inverse secant t minus, and then we'll get, this will be 11/4 then, and then it'll be the integral of 1 over the square root of u, or u to the negative 1/2 du. All right, when you make that substitution. You okay?
Yeah, I'm just looking at this. I have 1 over square root of u.
Right, which is the same as u to the negative 1/2.
So 1 over square root of t squared minus 1.
Well, we have to find the antiderivative of u to the negative 1/2. So what is the antiderivative?
Okay, so plug it in first. Okay.
Well, find the antiderivative first.
Yeah.
Uh-huh.
Find the antiderivative first and then plug it in.
Right.
So it's going to be 2 square roots of u.
Good, because you add 1 to the exponent, so that's going to be u to the 1/2 power, and then you divide by 1/2, but when you flip it. So now I have 2 squares of u, but I have 11 fourths in front, so that's going to make 11 halves. Square root of u, which u was the t squared minus 1, so it's going to be the square root of t squared minus 1, like that. Feel okay?
Yes.
Okay,
yes.
Now this we have to evaluate from 2 divided by the square root of 3 to 2, okay? And I'm going to notice that the 11 halves is common to both of those terms, so I'll just worry about the 11 halves at the end. So first I'm going to plug 2 into this, and it's going to be 4 times the inverse secant of 2 minus the square root of 3. And then I'm going to plug 2 divided by the square root of 3 in, which will be 2 divided by the square root of 3 squared is 4 over 3. Inverse secant 2 divided by the square root of 3. And then minus, okay, so 2 divided by the square root of 3 squared is 4 divided by 3, so 4/3 minus 1. So 4/3 minus 1 is 1/3. So that's the square root of 1/3, which is going to be better thought of as the square root of 3 over 3 if you rationalize it. Are you okay with that?
Yes.
Okay, now from here, we just have to figure out what the inverse secant of 2 is and what the inverse secant of 2 divided by the square root of 3 is. So the inverse secant of 2 means what angle gives me a secant ratio of 2. Secant is the reciprocal identity for the cosine. So that's the same as thinking what angle gives me a cosine ratio of 1/2. And what is that?
I got pi over 3.
Perfect, yeah. You can look on your unit circle to see that. Okay, and then we're going to subtract. Now this is saying what angle gives me a cosine ratio of square root of 3 over 2, which is what?
I got pi over 6.
Pi over 6 is correct, yeah.
Okay.
And then minus the square root of 3 over 3. Make sure you have this. Okay. And then, so now this is going to be 11 halves, and then this is 4 pi over 3 minus the square root of 3, and this will be minus, let's see, this will be 4 and 6. That's going to be pi over 9, right? 2 pi over 9. Does that seem right? Yeah. Minus the square root of 3 over 3. So this is 12 pi over 9 minus 2 pi over 9, which is 10 pi over 9. So this is 11 halves, and this will be 10 pi over 9. And then this is the square root of 3 plus the square root of 3 divided by 3. So you have a whole square root of 3, and then you're that's negative, and then you're adding a third. So that's going to make negative 2/3 square roots of 3. And then that should be it.
Okay.
Make sense?
Yes, I think I must have. I had something somewhere that